Welcome and thanks for joining us. My guest today is Mark Clancy, the Senior Vice President for Cybersecurity at T-Mobile. Mark, good to have you with us.
Thanks for having me on.
All right, federal agencies modernizing their networks. What are the latest that you're seeing in how they are adapting their cybersecurity strategies to help in these environments that are more and more cloud-based and mobile first?
Yeah, it's cloud mobile meets AI. I think that's sort of the big news, right? So everything that, it's all about connectivity, pervasive connectivity, working from anywhere, whether you're in the office or on the go, but also keeping everything secure. And as we have people who are not in traditional offices or not behind the agency firewall, right? Those kind of things are important that you always have security running and that it's always on and always present.
All right. So, mobile security, secure mobile solutions, how do they help agencies meet these federal cybersecurity mandates? We've got zero trust that has survived, all of the vicissitudes of recent years, and also TIC 3.0, which is still very much with us.
So let's take TICS 3.0, which is part of a zero trust footprint, right? You're really trying to make sure that things that go out to the internet are through a protected channel. And if using the service access service edge type solution, SASE platforms, you can now do that from phones using network slicing, right? So you can protect these devices that don't have a mobile client like you might have on a Windows machine or a Mac device, but you can get the same type of network security protections for devices when they're active on mobile or any other, Starbucks internet kind of thing, right?
Well, tell us more about that slicing idea. How does that work? And walk us through maybe how that would happen in a transaction back and forth between a cloud and a mobile device using federal, protected data.
Yeah, so a network slice essentially, I'll simplify it a little bit. Just think of it like a partition of a network, a virtual network inside of the mobile network. It's one of the features of 5G when you have a standalone core. And essentially you can partition the traffic to have specific properties, whether it's, latency or data priority, but you can also direct where the traffic goes. And so we can direct traffic from a 5G slice into a security gateway like a SASE platform to make sure all the connections to and from are brokered through that edge control.
So you have that with 5G in modern wireless, something that probably was not available with the earlier generations like LTE.
That's correct. In LTE, you had to do something that was a little more janky, to use a technical term, which was essentially route all the traffic back to a data center and then exit out to the internet through a gateway. It didn't provide a good experience. It also didn't allow for quality of service, right? So if you need to make sure you're in an emergency situation and these devices are working, and today we all know that first responders need to get to data as well as voice, you can do that through a network slice. It was very hard to do that over traditional networks as they were built in 4G and LTE land.
And the ability to have that slicing, is that something inherent in the devices, in the mobile devices, or is that something that issues from the cloud? How does it get invoked, let's
It's
say?
actually, yeah, it's actually part of the radio access network. So in the 5G specifications, and when you have what we call a standalone core, meaning all the backend routing infrastructure of the network is 5G based, it's a feature that you can turn on. Um, Now you can't, it doesn't exist in non-standalone core in 5G and it doesn't exist in 4G. So it's really one of these advanced features that you get from a pervasively deployed 5G network.
Okay, and I guess that then leads to the idea that your 5G provider should be just about everywhere you need to be.
That's correct. And what we have now is we have the advent of cellular-based LAN radios, but now you're seeing direct to cell. So one of the things we've been doing at T-Mobile is making sure that we have not only ground-based coverage but satellite coverage. We've started with messaging and we'll expand it from there. But that makes you able to reach those places that are hard to get to. Out in the backwoods. I live in Washington State, and there's a lot of places that are far away from a cell tower in Washington State, even where you have lots of cellular coverage, you're out in the woods, now you have connectivity.
Got it. And just a detailed question. If you are on the mainstream towered network of 5G, say like a T-Mobile, you have much more bandwidth perhaps than with satellite. But with the satellite, the 5G technical capabilities are still present, even with the
That's
low
correct.
bandwidth setting.
Yeah. I mean, it's a narrow network because, of course, you're serving, satellites, so there's more finite bandwidth. But obviously, when you're in the middle of nowhere, the density of people using that connection, that direct cell connection, is much smaller, right? And so it doesn't, from a performance perspective, it doesn't seem to have as much effect. If you're in a dense urban area, you want to be on a land-based cell tower.
Sure, but worst comes to worst, even the satellite situation, you can say send help or I'm late,
Correct.
like
Yeah,
that.
those emergency messages and get to and from, even when you're off the land-based network.
All right. So the other big issue in the modern cybersecurity idea is visibility. And so how can management ensure visibility and control when they have these distributed edge environments we've been talking about? Remote people, field operators, and the whole idea of Internet of Things, non-peopled parts of the network that are generating data and doing work for us.
Well, I think it's the intersection of two parts. One is sort of the inventory knowledge of what assets do we have, right? And how do you keep that, whether it's with traditional compute devices like laptops or with phones? The second piece is then how do you look at the configuration, the security status of those devices, right? You want to intersect those two things. And so the hard part in this is viewing your total compute plant, whether it's a phone or IoT device or a server or a laptop, as part of your asset inventory. And most entities now use managed devices in some fashion or other, whether they have a full mobile device management situation on the client, or they're using mobile application management for maybe like your office environment stuff. And you want to make sure those things are connected. And so when you do your identity plumbing for humans and your asset inventory for your devices, that all those devices are managed and paid attention to. And you connect your access policies so that you can only access from a managed device, for example, to critical applications.
So this takes, I guess, capabilities beyond just pure mobile device management to effectuate this.
You're correct. Yeah, I mean, it's sort of the process meets technology challenge, right? You've got people who use all these devices. You got to have processes to manage them that intersects with technology that's appropriate to the type of device it would be, whether it's a mobile device or, a server or a laptop.
All right. And, in recent months, there has been some turmoil in government agencies, people coming, a lot of them coming back now. There might be a little bit of a talent gap between what is available from industry and what is now in the government, at least at this moment. So, can public-private partnerships, how do they help bridge that talent and the technology gap so that these emerging threats and to infrastructure stay mitigated?
So there's kind of two relationship sets here. One is more traditional, supplier to customer type piece where you can provide services and close operational gaps. The other, where I've spent a lot of time, is really in the information sharing side of what are we seeing with the threats? What's happening in mobile devices, from, malware attacks to abuses or other, malicious activity like SIM swaps and those kind of things, and how we share information about what controls work, what threats are happening, and what things we're seeing in our environment, and then sharing that back, in our case, with government partners.
Yeah, I imagine a T-Mobile with its national coverage, or international coverage even, and information from millions and millions and millions of devices, you probably have a more comprehensive picture of what's emerging, what's going on, what's hitting different networks and infrastructures that you can share with any given customer that may not have the visibility that a T-Mobile would have.
That's correct. And one of the things we've been working on, although this isn't quite shipping yet, is how do we do analytics for individual customers, be they agencies or corporate entities, about what are we seeing about their devices they have with us on our network to help them better be informed about the threats that we're seeing and mitigating, or the threats that potentially are getting through and not being handled by controls on that agency's footprint.
All right, and then the idea of continuous authentication, I guess that's kind of derived from the original continuous monitoring, but really, since everything seems to be surrounding the identity idea, this idea of continuous authentication, identity-based access controls, what are some of the challenges you're seeing there that agencies face in having that capability?
Kind of two parts of the puzzle. One, like, still too many things rely on passwords, right? And so part of the challenge we've done at T-Mobile is we've moved our workforce to entirely passwordless. We happen to be using FIDO2 tokens, agency contacts, CAC cards, and the, kind of other cryptographic validation methods work. So that's sort of part A. That's how you you authenticate somebody. This idea of continuous validation is saying you don't want to just do it once, you want to do it all the time. Because what if the session gets hijacked? What if, somebody changes a session from device A to device B? You want to re-authenticate and make sure that party is still who they say they are. And many of the cloud and SaaS services support this type of capability, but a lot of your legacy platforms don't. And so we have to just figure out how do you migrate to centralized identity store, like something around Entra or whatever, and how do you converge all of those islands that you have to that they're in a single identity plumbing, a single authorization authentication plumbing, and then you can add business rules around what refresh times, what timeouts exist, and so you can revalidate. There's another category of continuous validation, which is more in the checking the characteristics of a session and see how they change, and then force reauthentication if my example of moving from device A to device B type thing happens.
Now, people, users are used to the, even though it might be annoying, but they are used to years and years and years of passwords and having different passwords for different things. What does it look like from the user standpoint in a password-less environment? I mean, if there's a token, you have to enter that token number, that type of
Yeah,
thing. What does it look like?
yeah. So if you're say you're in a Windows a laptop that uses Windows Hello for Business, which is a Microsoft feature, it's using a trusted processor model on the laptop. You are entering a PIN or a biometric or a fingerprint to unlock that cryptographic authenticator on the device, and you open your browser and you're just signed in. And so the user experience is very good. We do the same thing with devices using FIDO2 tokens. So those are like those UB keys. You
Mhm.
put the UB key in, you touch the button, you put in the PIN, and now you're cryptographically authenticated and you just go about your business. And so it's really simplified the life. We reduced our help desk volume by 40% because we're not doing password resets every week. And so people are just able to get in and be productive right away.
Yeah, I guess it feels like you're not doing the right thing, but in fact, you're doing a much stronger thing than you were with the password.
Yeah, it's one of these weird things where we got better user experience and better security at the same time after a lot of hard work to get there. I won't diminish that part. There's a lot of effort to get it to happen.
Sure. And earlier we mentioned AI meeting the whole cloud infrastructure idea. And so people are trying to figure out how to use AI in the service of better security and better access controls and all of this. At the same time, they're trying to battle AI, which whatever the bad folks out there are trying to do against the agency. So you've got kind of this dual-faced nature of AI. What are some ways of dealing with that?
Well, I'm going to start with the malicious use of AI. Like right now, you are being attacked by actors who are using AI to make their attacks, whether they're phishing campaigns, just tremendously more compelling, or they're probing your perimeter and looking for holes, gaps, and seams. And so you may not have aggressive move forward with AI projects yet in your agency, but your bad guys are using them against you right now. Like that's just happening, whether it's deep fakes or kind of text driven things. So the first thing you have to recognize is like whether you're in the AI game or not, you're in the AI game because your adversaries are using it. On the defender side, we found a lot of efficiencies where, just simple things like using a LLM tool to create queries in the security tool. So if I have an expert who really knows Splunk really well, and now they have to go write a KQL query in Sentinel-1, like they can just give it the instruction and it'll give them the query and they can go run it. They don't have to go learn this new language themselves. And so their productivity in terms of hunting and searching for bad activity goes way up. So that's sort of one thing. The second thing we've been looking at is what if we start testing ourselves using AI the same way an adversary would to find those gap seams and warts before they do. If you look publicly, Hacker won the top leaderboard on their bug bounty testing is right now an AI agent, and it's finding things faster than humans. That kind of tells you where this space is going.
Yeah, so the battle of the bots, you might say, is not just
Correct.
a cartoon concept, but something really going on in cyberspace.
Exactly.
All right, and then 5G itself, as we kind of bring this around here, has become integral pretty much, I think, across federal operations, and that's just the way it is now with the big carriers and their levels of coverage. What are the specific cybersecurity considerations agencies factoring into mobile and wireless?
There's a few. First of all, in 5G, there are some protections because it's a more modern standard. It has more security features built into it than 2G, 3G, or 4G, right? So you just have that sort of, you get more security, the more mature up the ladder you go. I think a big thing that we've spent a lot of time on with government customers is really understanding how location tracking can work. So when you're on a 5G network, you can't be downgraded to older technologies, which means people can't hijack the phone and connect it to another device like a IMSI catcher, IMSI catcher. So you have kind of those protections. You also have protections on the subscriber identity because of essentially cryptographic handshake that your phone does to the tower. So you can't, somebody intercepting the signal can't tell that it's your device. And then you take it forward and you have other protections in the network core and the signaling setup that makes it more difficult to attack, right? So you have kind of all those pieces. In terms of the day-to-day operation, really what you get is a more secure, higher speed connection because of the way the protocols work and the way that we're using bandwidth on the various spectrums to get a better reliability of the service as well.
So really then the mobile first idea, which has kind of taken hold several years ago on developing new applications and interactions within an organization, within the government, or between government and people, really that mobile first idea sounds like a way that you can also be maximum security nowadays.
It increases security, and the devices have come a long ways, right? Like, so Apple devices, for example, have this thing called security on a chip. And basically, there's a trusted processor module in the phones that can store cryptographic keys safely, right? And so for many high security needs, maybe not classified activities, of course, but like high security demands, there's a lot of features in these phones now that you can leverage as you build mobile apps. You take advantage with those on top of a high reliability, high security network, and you get pretty good controls. It's come a long way.
All right, we'll leave it at that note. I want to thank today's guest. Mark Clancy is the Senior Vice President for Cybersecurity at T-Mobile. Thanks so much for being with us.